Hello everyone, how are you? I hope you all are fine. Today our session is Werner's theory. Alfred Werner in 18th century start discovery of the structure of this compound, coordination compound. He was first started the structure of the coordination compound. Basing on his observations, he observed the primary valency and secondary valency of the compounds. What is the primary valency? Now coming to this, a metal atom have in these primary valency compounds, the metal atom has negative charged ions. The primary valence compounds are dissolved in water, it forms ions. These are negatively charged ions. Now coming to the secondary valency. The secondary valency compounds are metal atoms combined to the negatively charged or neutral ions or positively charged ions. These are combined either negatively charged or neutral or positive charged ions. These are not dissolved into water. The primary valency represents the oxidation state of the number. The primary valency represents the oxidation state of the complex. Oxidation state of the complex. In the secondary valency represents the coordination number of the complex. It represents the coordination number of the complex. Primary valency represents the oxidation state of the complex. Secondary valency represents the coordination number of the complex. Primary valency is represented with the dotted lines like this. In secondary valency represents the straight lines. Now coming to the structure of these compounds. For example, see here how we write the structure of the complexes. NH36. In this complex, this is the central metal atom. Cobalt is the central metal atom. If you write the structures of this complex, we know the difference between the primary and the secondary valencies. These are the different structures of the complex. I write the structures here. See here, CO is a central metal atom cobalt. It has 6 ligands, NH3, ammonia, 6 ammonia molecules. It has CO, Cl3, NH3, 6. This is the central metal atom cobalt. NH3, 6 ligands are around the central metal atom. Here Cl3 ions are there. These are represents like this. These are the primary valency compound Cl. Here Cl, here one Cl, here one Cl. Any space in this complex we represented with dotted lines. These are the primary valencies. These dotted lines represents the primary valencies. These straight lines represents the secondary valencies of this complex. How many ions present in this complex? Finally, CONH3 6. The complex bind with 6 ligands. These are the Cl3 molecules, 3 Cl3 molecules. These coordination sphere represents the one ion. This Cl3 has 3 ions. Ionization sphere has 3 ions. Total 4 ions present in this complex. This is the structure of this complex. Now coming to the COCl3NH3 5. Write the structure of this complex. Cobalt is the central metal atom. See here, in this cobalt is the central metal atom. Ammonia is 5 ammonia molecules are attached to this central metal atom like this manner. But here we have 3 chlorine atoms, but we have 5 NH3 molecules here. 5 NH3 ions, 5 ligands are present in this complex. 3 chlorine ions are present in this complex. One is write like this. This represents the both primary and secondary valencies. The remaining two you write like this anywhere in the complex. Why? Because we write here no NH3, here no NH3 ion, only 5 NH3, 5 ligands are present in this compound. That's why here we have a empty space. This empty space is occupied by the chlorine atoms. The remaining 2 chlorine atoms write like this. How many ions present in this complex? Here CONH3 5, CONH3 5, Cl3. These are the 3. How many ions present in this complex? Here one chlorine ion behaves as a dual nature, both primary and secondary. That's why you don't consider this one. Here Cl2, 1 plus 2 is equal to total 3 ions are present in this complex. Now coming to this complex. Carbon is the central metal atom. Here these are the 6 ligands around the central metal atom. Here we have 2 empty spaces. 4 ammonia molecules are occupy the 4 places. 2 empty places we have. These are fulfilled by the chlorine ion. Here 2 chlorine ions behaves as both primary and secondary valencies. One is write like this. The complex is CONH3 4 Cl2. How many ions present here total? Here 2 chlorine ions acts both dual nature, primary as well as the secondary. That's why how many ions present here? 1 plus 1. 1 chlorine atom present here. Total ions are 2. The remaining structure is COCl3 NH3 thrice. In this complex, cobalt is the central metal atom. Here the 3 chlorine atoms are write like this. These 3 are acts as a dual nature, both primary and secondary. There is no ion formation here. There is no ion formation in this complex. Now coming to the applications of this